Hello and welcome. If you're watching this video, this means that we're going to be brushing up on some inequalities, in particular with multiplication and division. Last time we checked on addition and subtraction and we found that there was no funny business whatsoever. So if we were to take any random inequality, we would be able to use inverse operations to add or subtract any number we wanted and nothing funny would happen. For instance, if I took 4 less than 10 and I happen to add 1 to both sides, I would still get a true statement. Here we have 5 is less than 11. Similarly, we could choose any number we wanted to subtract, and again, no funny business. So starting with 4 less than 10, taking away 3 this time, and that would give us a new inequality, 1 less than 7. But with multiplication and division, we're going to have to be more careful about which numbers we're choosing to multiply or divide between. Let's take a look at some examples to see some of this strangeness that's going to pop up. Now what I've done so far is I've given us a number line and that inequality that we just worked with a moment ago. And what we're going to see is, depending on the numbers that we multiply or divide with, this inequality is going to make sense or something's going to go terribly wrong. Let's take a look. So let's say I happen to take this inequality and multiply both numbers by 2. Starting with 4 less than 10, if I were to multiply both sides by 2, that would give me 8 less than 20. Now thinking about my number line, here's where 8 would be, here's where 20 would be. Is 8 behind 20? Yes. So nothing weird happened there. Let's try our next example. Let's try dividing our starting inequality by -2 to see if that creates any weird happenings for us. Okay. So if I were to divide both of these numbers, 4 less than 10, divide it by -2, divide it by -2, I would get -2 less than -5. So let's see. Here's 0. This is where -2 would be. -4 because I'm counting by 2's. -6. And -5 would be right there. -2 less than -5. That would mean that -2 would have to be behind the -5, but it's not. It's in front. So this one is false. There's something strange going on here. Let's try dividing by just a regular +2. Let's see if that causes something to happen. 4 less than 10, and if I happen to take these and divide each of those by a +2, I would get 2 less than 5. Alright, let's see. Here's 2, 4, 5. Is 2 behind 5? Yes. Okay, so that one's fine. What I've just done for you is I've given you a short little hint that there's something fishy that goes on with negative numbers. And when we multiply or we divide by positive numbers, we're going to get what we expect. Now, of course, this isn't a proof because I haven't shown it for all numbers, but we're just going to let 2 and -2 be our examples for any numbers out there. It wouldn't matter if it was 3 or -3, we'd notice the same behavior. So if you were going to multiply or divide with positive numbers, everything's going to be okay. You're going to expect the numbers will be in the order of which you want them to be. However, if you multiply or divide with a negative number, something strange is going to happen, and we're going to have to counteract that. So we're going to have to fix that by what I call flipping the inequality. Alright, so essentially what that means is whichever way your inequality is facing, either this way or that way, you're going to turn it around if you multiply or if you divide by a negative. Let's try some basic examples. So here I have 3x less than or equal to 12. Well, I can undo this times 3 with a divide by 3. And I know that 12 divided by 3 is going to give me 4. Now since I divided by a positive number, nothing strange is going to happen. That inequality is still going to be facing the same way that it originally was. However, over here with this second example, To get x by itself, I would have to divide both sides by a -6. And as we saw just a minute ago, that's going to cause something weird to happen. So it's okay, we'll still get -4, but to counteract that weirdness, I'm going to need to turn the inequality sign around. Notice how it's opening the other way. First it was opening to the right, now it's opening up to the left. So this would be an example of x is less than 4. Here, let's look at this example. I have x divided by 6 is greater than 8. I can undo this divide with a times. So times divide cancels out. X greater than 48. And notice that I just wrote the greater than right away because I was multiplying by a positive number. Nothing to worry about there. Here, x divide by 5, so if I want to undo divide, I will use times. So times 5 on both sides. Cancels out our division. X greater than 20. Again, no need to flip it because I'm using a positive number. I am multiplying by a 5. Let's look at our next example here. X divided by -3. Well, to undo that divide, I need to use a times -3. But now I'm feeling kind of weird because I'm multiplying by a negative, which means I need to flip that inequality, and I get a positive 30. Negative times negative is positive. Now I'm going to pause right here because this is an important problem out of all 6 of these. It doesn't matter what the final number is, it matters what we're using. So notice here in this example, I multiplied with a positive 5. That's okay, I'm using a positive. But in this example, I'm multiplying with a negative, that -3, and then I need to flip the inequality. So it doesn't matter whether your end result is positive or negative, it matters which number you're using in the process. And let's take a look at this last one. 7x, alright, that's a times, so I will divide to undo that, and I will get -5 greater than x. And again, it matters which number I'm using. I divided with a positive 7, so here there was no flipping involved whatsoever. I want you guys to pause the video and try these problems on for yourself. Now, these problems involve both multiplication, division, and a little bit of addition, subtraction. Remember that with addition and subtraction, nothing strange is going to happen, so leave that inequality where it's at. But when you try to use your multiplication and division steps, be wary of those negatives. If you multiply or divide by a negative, make sure you flip the inequality. So if you haven't already, pause this video. I'll just wait here for about 2 seconds and we'll go over the answers in a little bit. Alright, it's time to go over these one at a time. Let's look at our first example over here to the right. I see that I have 4x plus 3 less than 27. I'm going to want to take away 3 to help get my x's all alone, which leaves me with 4x less than 24. I got to divide to get rid of that times 4, and I know I get 6, but should I flip it? No, we're not going to flip it this time because we divided with a positive 4. Positive numbers are okay. For our second example, I put this here because I was wondering to see who knows how to combine like terms. We have an 8x and a minus 13x. When I subtract those, I will get negative 5x, and this minus 8 stays there, and that 22 stays there. Now this looks kind of like our last problem where we just have 2 terms. I will add 8 to both sides, giving me 30 over here, and I have a negative 5x. So now, just like last time, I will want to divide both sides by negative 5, but unlike last time, now the inequality flips because I have divided by a negative number. Alright, here we go. Ooh, a fraction. And this is what I like to call a big divide because we have a lot of terms over this division. Well, I know that I can get rid of division with a handy multiplication step, but I would multiply both sides by a negative 3. Well, that means the inequality flips. negative times negative gives me a positive 15, and this little x plus 12 here is left over. But I don't want x plus 12, I just want x by itself. So I need to take away 12 from both sides, giving me x is greater than or equal to 3. So what was different about this last one was we ended up flipping it at the very first step of our problem, whereas with our second example, we ended up flipping it at the very end. That's just going to happen depending on the numbers that are given to you in your problem, but what we need to pay attention to is when we're flipping it, and that's when we multiply or divide by a negative. So those are my helpful problems. Let me know if you have any questions, and I will talk to you soon.